All right, example 5. You know what I'm looking forward to?
Swine Week?
Swine Week. Swine Week's next week.
Yeah, me too.
As of when we're recording this, it could, when you're watching it, perhaps be the actual week.
Or
right?
it could be way past, depending on
not.
viewing history.
Yeah.
So if you're not one of our students and you're somewhere else, then you're missing out on the glory that is.
Yeah, so there's a website. You could look it up.
It's possible next week's videos I could have a different hairdo.
Quite possible. Or we could be dressed funny. Whatever. All right, example 5. Now these are, I would say, the trickiest part of the lesson.
Yeah, these are hard.
But they're not actually. They're not really that hard.
You have to think differently.
Yes, exactly. So we want to describe how to transform the graph of f of x equals the natural log of x into the graphs of the given functions. Sketch the graph and support your answer with a grapher. So what we want to do...
I'll say on this one, sketching them will be difficult.
Yeah.
Anyway.
A little bit.
Yeah, but there are some things that we should be able to see.
Yes.
By hand without graphing.
Right.
Yes.
And so the way we want to start off here is using the change of base formula.
Yep, indeed.
And we have the natural log of x over the natural log of 5.
Now, remember, natural log of x graphs just like all the other fractions and functions and everything else. And so this is not natural log of x over natural log of 5. This is 1 over natural log of 5 times the natural log of x. And that should help us see exactly what's happening with this.
Yes, because now this is either a vertical stretch or a vertical shrink on ln of x, depending on whether or not that number is greater or less than 1.
Right.
Off the top of your head, do you know?
No, I'm going to say probably bigger than 1.
So it says, I mean, obviously we would want to do this without graphing it on our calculator at first, but you would be able to probably...
Ooh, I was right. 1.6, baby. It's less than 1 because it's 1 over that.
Okay, so natural log of 5...
I was partially right. I knew the natural log of 5 was larger than 1, but 1 divided by that is less than 1, which means that we have a vertical squishing.
This is a vertical shrink of...
Natural log of 5, actually.
Well, of
1 over
the natural log of 5.
Yeah.
Or 1 over 1.609, right. Or you could divide that out and see what that is.
I can whip that up real quick.
So
0.6213.
So now, really what's important is you've got to get the hang of what the natural log and all these other logarithmic graphs look like. They all are going to start at 1, 0, unless there's a shift.
Right. But there is no shift in this case because we're not adding or subtracting any numbers anywhere.
Right. So if it shrinks, it's basically going up about half as much. Well, that's really difficult to show on a graph.
Right.
So,
which is why I said at the beginning that actually graphing these by hand could be tricky. But if you were to graph natural log of x and then graph 1 over natural log 5 of natural log x, you could see a difference.
You should see a difference. And this is really, to me, the important part, this work that we did to get here.
Yes.
That's the really important part of this problem.
Right.
So let's try another one.
Okay.
So this is natural log of x over natural log of 1/4. I feel like the fact that this is a fraction may end up giving us a different result.
Yes, I agree with that 100%.
Because now we've got 1 over the natural log of 1/4 times the ln of x. And what is 1 over the natural log of 1/4?
Well, I believe that's going to be negative natural log 4.
Okay, which is what?
Well, if you'll just give me a second to punch it in instead of rushing me, because I don't work well under pressure.
Okay.
Negative 1.3863.
Say it again. Negative
1.3863. That's what's in the denominator.
So we have a negative, which means that this is a reflection across the x-axis.
Oh, I was right.
And 1 over 1.3. Congratulations. Are you going to do 1 divided by that or no? Okay, this is a vertical shrink.
It's cabbage patch. Cabbage patching. I got you right now. Negative 0.7213. Got that right.
Or, actually, it's not a shrink with that negative.
No, the negative can't be there for the shrinkage. But it would reflect over the x-axis that way.
Yes, that's why I wrote
Yes,
reflect across
yes,
x-axis.
yes.
Yeah. And so if we graph this, this is a little trickier. I'm going to graph this over to the side of our faces, not on top of them.
I'll just double check you because this one is a little tricky.
Okay, 0 or 1, 0, that's our starting point. Normally, we are reflecting across the x-axis, so that moves it this way, which means it still stays where it's at. And then we are shrinking, but it's going to go this direction and this direction. Think about basically, these are actually really close to each other, right? Except that this one's flipped. So think about flipping this right here. Well, it looks kind of like what I drew there.
Yeah.
So,
Should be similar.
yeah, that's all there is to it.
There you go.